All right. Hi, everybody, and welcome to episode number 5 of Learning Golang from Zero. My name is Paul Kernfeld, and I'm a member of the technical staff here at Cockroach Labs. This series, the idea is that you can follow along with me as I'm learning Golang, which is the primary language that we use to write Cockroach DB and also everything else that we work on at Cockroach Labs. So, for the first episodes, we started with just a simple hello world program, worked through some integers, slices, arrays, functions, testing, so on and so forth. And now we're up to pointers and errors, which is going to be the subject of this episode. And I am actually really excited about mostly errors, I would say, because I think that error handling is one of the hardest things about making a programming language usable for programmers. And I really think that error handling is absolutely an unsolved problem. I would say that error handling is one of the most distinctive aspects of a programming language. And it really tells you a lot about the philosophy of that language. I think pointers are also going to be pretty interesting too. In particular, one of the questions that I want to know the answer to is how is Golang going to keep us from accidentally shooting ourselves in the feet by using some sort of dangerous pointer arithmetic like you might see in C or C++. I'm curious for anybody who's tuning in right now, what programming languages are you already familiar with, or are you already familiar with Golang? So I'm going to start. This book, by the way, is called Learn Go with Tests. I think it's really great because not only does it explain Golang concepts, but it also lets us test our knowledge by writing unit tests and then verifying that we can write the correct code to get them to pass. So it looks here, yeah, we just finished up structs and interfaces. By the way, I have been thinking about it, and I actually think that structs, sort of the struct and interface system, what you might call the object-oriented programming aspects of Go, might be my favorite aspect of the language so far. What I like about it is that it's just insanely simple. And it doesn't have any of the weird gotchas that you see in so many other languages. So for here, it looks like we're going to be putting together some simple cryptocurrency primitives. That's pretty exciting. So we're going to make a wallet struct and deposit some Bitcoins into it. I love that. I used to be pretty big into cryptocurrencies, although I will admit that I have not stayed up to the times very much. So I'm going to make a new thing called a new folder. Maybe I'll call it wallet, or maybe I'll call it Bitcoin. And then I'm going to start with a file called, actually, I'm going to start with the Bitcoin test.go. What we're using here is test-driven development. It's a really great development style where you actually write your tests first, try and get them to break, and then you implement your production code that will make your tests pass. And it's a really good way to check that everything that you're working on has good testing for it. So previously we learned about structs. We're accessing fields with the field name, but this wallet is very secure. By the way, this is a joke. I think hopefully people will know, but I guess if you're a beginning programmer, you might not know this, but this is kind of talking about public versus private fields in the context of a programming language, which is not really the same as keeping data private on a real blockchain. On a real blockchain, you would need to use some kind of cryptographic security to ensure that somebody can't break into your wallet. So yeah, just maybe a heads up that this person, when they say very secure wallet, they are Joking. But this is a really great concept that we're going to be learning about here. This is the concept, I guess I would call it encapsulation, where the object is going to have certain aspects that are not publicly visible to external users. Curious, where are people tuning in from today? Previously, I was streaming at 9 a.m. Eastern time, but we just moved it to noon Eastern. And so I suspect there's going to be a pretty different composition of viewers for this stream. So what are we doing in this test wallet? We're making a new wallet. We're depositing 10 Bitcoins into it. That's pretty cheap. That's only about $650,000 this week, I want to say. So great. We're depositing 10 Bitcoins. And then we're going to print out the wallet balance. And the wallet balance is 10. Okay, that makes sense. We want to deposit 10 and then we check that the balance is 10. So yeah, let's try running the test. So I do this by doing go test dot. Okay, so we got people tuning in from so we got Switzerland, Arizona, North Carolina, NYC. Hi, Lauren. So I actually, yeah, great to hear that we got a viewer tuned in from Tempe, Arizona. Upinderjeet, thank you for tuning in. I'm guessing you probably would not have tuned in 3 hours earlier than this. So that's kind of why we moved the stream a little later in the day. Okay, so I ran gotest dot. My problem is I just pasted their code, but I actually need to write the package name up here. So I think I can do like package main. Hey, Dan, sunny Seattle, Washington. You know, I was actually thinking about moving to Seattle, but it was too gloomy and too far away from my friends and family. So I decided not to. Okay, so oh yeah, I've got an undefined testing. So I need to remember, I need to import testing. And yeah, so now we're all the way up to undefined wallet. So now we want to write the minimum amount of code for the test to pass. I need a new wallet struct, and I need to have a deposit and balance method on the struct. Let's see if I can remember the syntax for this off the top of my head. So we got to put it in a package main, and then I think I write type wallet struct, and we'll see how well that works. And I'm not going to actually put any data in here because what we're trying to do is we're just trying to get this to compile. So I'm going to I need to now add a method to this. Oh boy, do I remember how to add a method to a struct? I'm not going to lie, I don't think I do. So I got that part correct. Fine. Okay. I need to write func, and then I actually pass in this little parenthesized type. So that we got the deposit amount. One weird thing about this financial system that we're constructing is the Bitcoin are not coming from anywhere. In real life Bitcoin, you need to actually, the Bitcoin would need to come from another Bitcoin address, or they can be mined. I wonder if somebody has implemented Bitcoin in Go. I would guess they probably have. And so, yeah, we need a return statement to get this to compile. And what we want to see now, we want to see that the code will compile, but that the test will fail. So far, so good. We've got this message got 0, want 10. So let's try and store some data in the wallet. I'm going to make a balance field. I think is int a type in Go? I think I've forgotten the first lesson of this thing, which is how, like the first episode of Learning Golang from Zero, we did integers, and I don't remember how to do integers. So I guess we would do, I don't think there's a plus equals operator in Golang. I'm going to try anyways. I'm pretty sure that there is not, though. And then for this, I'm going to do just return w.balance. I think I'll get a, oh, that's actually quite interesting. I guess there is a balance, there is a plus equals. So I think I've done something wrong because I don't know. I feel like this code should work. Let's just explicitly write out what's happening here. Just to say the balance equals balance plus amount. And my guess is because we're learning about pointers, what happened here is that we probably modified the balance on like a copy of the wallet, and then we didn't actually access the same wallet in the test. So my guess is that we're going to have to use a pointer to the wallet at some point. This actually seems like a pretty easy way to shoot yourself in the foot. Anybody have any suppositions about what's going wrong here? Did I like just make some dumb mistake in my code here? Okay, so write enough code to make it pass. Okay, they did the same thing I did there. That's a good sign. And this symbol, balance, starts with a lowercase. So that means that it's actually private and we can't just write from the test. We couldn't write like w dot lowercase balance from the test, which is great. It keeps people from modifying our wallet balance. So, okay, this is actually exactly what I did. And I think, yeah, okay, so we got up to this point and we've got a lot of question marks. So I guess now we got to figure out what's going on. In Go, when you call a function or a method, the arguments are copied. So when calling this, W is a copy of the wallet. Okay. So that makes sense. What happened is, even though we thought we were modifying the balance of the wallet, we were actually modifying the balance on a copy of the wallet. So now we need to get a reference to the original wallet so that we can modify the original wallet. I'm not going to add these print statements unless people are like jazzed about that. I think instead I want to just, I want to fix the, this is actually pretty cool what they're doing. I don't think I'm going to do it, but what they've done, they've used some sort of magical, so they're using this ampersand symbol to get the address of the wallet balance. And that's, the address is like where that data resides in memory. And what they're showing is that the address of the copied wallet, the address of the balance in the copied wallet is different than the address of the balance in the original wallet, which is bad. And so these start with a similar OXC4200, but they end with 68 and 60. That's actually kind of interesting. So these two things are actually really, really close to each other in memory. They're 8 bytes apart. I think it makes sense that would happen, but I wouldn't necessarily have guessed that they would be so close to each other. I find that pretty fun. Curious if anybody knows if this stuff would go onto the stack in Golang. I think it could, because this struct type should really only need to be like whatever the size of an int is. I'm guessing 8 bytes. One question that I ask actually usually when I do this stream is, are people already familiar with other programming languages? Like, I know if you're familiar with C or C++ or even like Rust, this pointer stuff would probably be pretty familiar to you. But if you're coming from a language like Python, you might be like, why do we even need this pointer stuff? So definitely curious if people are already familiar with pointers in other languages. So what we did here, we're making a really tiny change. We just need this star wallet, which means that the type that we're actually taking a pointer to the original wallet instead of copying it. So then when we copy the pointer, it's still going to be referencing the same situation. Let's rerun the tests and see if they pass. Okay, they passed. That's great. Do people get this? Does this seem like magic to you, or does this seem like, oh yeah, that's like, that's how pointers work? Of course, this would happen. Ah, okay. So, and pointers to structs even have their own name, struct pointers, and they are automatically dereferenced. So that's a pretty nice little feature here where we actually didn't have to write star W. Star is the dereference operator in, I guess, Go, I think C and C++, and also Rust. And it's kind of the opposite of the reference operator, which is an ampersand, which we used up here when trying to print out the address of each balance. And it's probably a gross oversimplification to say that star, like I wouldn't say that star means exactly the same thing in all of those languages, but I'd at least say that it has similar connotations. So let's do a git commit because I see that we have a refactor coming up. Do a git status. I seem to have opened Vim. That's not what I meant to do. So I'll do a git add dot and then git commit -m add Bitcoin. Anybody here big cryptocurrency enthusiasts? Do you like to write your own crypto applications in Golang for practice? I tried to write some crypto software a number of years ago. It actually did work. It was a tool for probabilistic micropayments. The idea is if you need to send someone a really tiny amount of money, rather than actually sending them like a billionth of a dollar or something, what you do is you actually send them $1, but with a 1 in a billion probability that the transaction will complete. People did not like this system at all. However, I think that it was technically a pretty decent idea. I could see it being used for, I don't know, like a situation where your like phone is like paying some public router tiny nano payments for incremental internet use. It did not catch on, but it was a fun idea. People don't like it because it's like gambling. So we're making a Bitcoin wallet. That's great. Okay, so we're gonna make a type alias that the type Bitcoin is an int. Yeah, that's interesting. I'm down with that. So I like type aliases sometimes. What they're doing here for us is they're giving us a little way to label the Bitcoin type, or rather the type of the balance. However, what I think is like, it doesn't actually prevent us from taking just a normal int here. I'm going to verify that now by running the tests again, but I think it will probably let us mix int and Bitcoin types, which might not be as safe as we want it to be. Oops, I did something wrong. I wrote balance when I meant to write Bitcoin. Ooh, okay. I was wrong actually. So this, in some other languages, when you make a type alias, it would let you mix Bitcoins and ints. But in Golang, apparently, now that we've defined this Bitcoin type alias, we cannot pass an int in to be used as a Bitcoin. I like that a lot for a situation where you want to have some kind of like compile time guarantee that people aren't passing in the wrong kind of ID. One thing that one thing that this reminds me of is like, let's say that you have like a game and you have a player ID versus a monster ID or something like that. And you would get in trouble if you try and pass in the player ID as if it's a monster ID, even if they're both an int type, because you might have, a monster that exists, but there's no player with that same ID. So if you use this type of type aliasing, you could have the player ID and the monster ID be both ints still, but it would prevent you from accidentally mixing them. I'm a pretty big fan of that. I know in Scala and Rust, and maybe also, I want to say also, I'm not sure, but yeah, are people used to this type of type aliasing letting you mix or not letting you mix? I feel like I would have expected it to let me mix, but I like that it doesn't. So what we have to do here is in our test file, we have to actually wrap this 10 in a Bitcoin, because otherwise the 10 would just be an int, and then the want. Now, something interesting here is when we're doing this check, it seems that it has all like automatically added the ability to check two Bitcoin values for whether they're equal to each other. So I think that's nice. I like the syntax for this. Let's check that the test actually passed. So maybe a git commit. This is like a Bitcoin. I would call this maybe a new type. In Rust, it would be called a new type because you can't mix it with the other type. But I think in Go, we're just calling it a type alias, which is cool. So let's make this stringer interface. I believe that we don't actually need to define this interface. I think this is defined as part of the format package in Go. So we'll open bitcoin.go and let's implement string. And I guess they've given me the text for doing this. That's nice of them. Ooh, do you normally put this before your wallet functions? Oh, this is for Bitcoin. It's not for wallet. Ah, okay. So we're actually adding a little bit of custom. We're adding a little custom logic to our Bitcoins. That's fun. When we print it out, it's actually going to say BTC rather than just saying the integer itself. That's fun. And I think I'm going to need to import the format package because I'm using format.sprintf. And are we gonna write a test for this? Ooh, okay. We're not going to directly test this, but we are going to modify this. So %d is to format something as an integer, but now we're using %s, which is to format something as a string. And I think that means it's going to call our stringer function. And so let's deliberately break the test as it suggests and run the test. And we should see that it prints BTC after each value. That's great. So now we should go back in and fix the test. By the way, I turned on syntax highlighting in my Vim, so we now have a little bit easier to read Golang syntax in Vim. So let's do a commit here. This one is a Bitcoin stringer or something. I've got here, when I do a git commit, is it actually runs all the tests and it will reject the commit if one of the tests fails, which prevents me from accidentally committing bad code. So now we need a withdraw function. Maybe I can start working on a withdraw function myself. So one thing that I'm thinking about that's interesting with a deposit function versus withdraw, the withdraw actually could fail. So probably this is where we're going to get into errors, because if I try to withdraw 20 but I only have 10 in the wallet, then we're going to have a withdraw failure, I think. So we'll have to return some kind of not enough balance, I guess, error. And let's see what they've got here. Oh yeah, we're going to write a test first. I think I'll just copy their test. So what they're doing here, they don't have any concept of a withdraw failing. That's all right. I'm guessing we're going to add that later. But right now we have 20 balance and we're trying to withdraw 10. I think the real interesting question here is what happens if you have 10 balance and you try and withdraw 20? The code doesn't really handle that yet. So looks like I have a syntax error in bitcoin.go. I probably just didn't write this withdraw function. Let's now do w.balance equals, oh, and I think I can do the plus equals up here. And then at the bottom, presumably I can use minus equals. So that looks pretty straightforward, but we're not actually handling the error. Looks like we're good. So I'm going to do a git commit. Withdraw is the name of the commit. Git commit -a will add all of my modified files, and -m will set the commit message to withdraw. So refactoring the tests, what are they doing here? Geez. Okay. Yeah, this is fine. I don't know. Maybe a little bit of like premature refactoring here. I think I've heard a rule of thumb that's like if you have if you have 2 copies of a piece of code, it's fine. If you have 3 or more copies, then you should refactor it. I think that is probably a little bit silly as a rule, but there's some wisdom to it. So in this case, we have only 2 copies of the code and we refactored it. Shaquille, hello. Where are you tuning in from on Periscope? So what happens if you try to withdraw more than the account? It is idiomatic for your function to return an error. Let's try it out. First, we need a quick refactor. Refactor Bitcoin test. And let's see what the test looks like. So we're throwing in a new test that's withdraw insufficient funds. In this case, the test now needs to return an error. Sure, that makes sense. And now that we have 3 tests, according to the rule of code is only allowed to be duplicated once, then we would have had to refactor anyway. And I accidentally messed up the indentation somehow. Oh my gosh. I forget if I have. So I've got this Git hook set up for running my tests pre-commit. I'm going to run a Go format and see what that does. Then I'm going to do a git diff. Oh yeah, my formatting had some mistakes. Yeah. Wow. Well, I don't think it's actually going to let me do this commit because I added a partially broken test. So I'm going to do this no verify flag, which will ignore my commit hooks. Oh, Abraham, you're tuning in from Nigeria? Is that the case? Oh man, I think that this would be that's the first viewer from Africa that we've had on the stream. I'm so excited that you're tuning in. I'm really excited about the African software development community. I feel like it's like the next big thing. So I think that my goal in the future is to have one viewer from every continent except for Antarctica. So the issue here is that what did I do? It says withdraw is used as a value. I probably pasted something wrong. Oh yeah. So I need to make my withdraw function return an error. Bitcoin.go. So I think this needs to return an error like, I think the type is called error. And this still won't compile because I don't have a return statement. I can show you guys that. If I try to compile it, it's going to say missing return at end of function. Cool. So what I need to do is I need to add this return statement. I'm going to do an if statement. So if the balance is less than the amount, then I'm going to return an error. And how do I do that? I feel like it's, there's a way. I did this just yesterday, making a new error. There's a bunch of different ways to do it. I don't actually remember how I do the new error. So let's see. In the end, I need to do this return nil, which means there was no error. But how do I return the error? Errors.new. Okay, makes sense. Errors.new. And this is not a good error message. I think it's a good place to get started. But the issue with the errors.new is like, this error doesn't tell us what the problem was. It should say something like insufficient balance. It doesn't tell us what the amount was, and it doesn't tell us what the balance was. So I think a good error should actually print out all of those pieces of information. Oh, remember to import errors. I did not remember that. So let's do that. And I think maybe our tests are going to pass now. Nice. So let's do a git commit. And this message is going to be like return error. More refactoring. So let's make a quick test helper for the error check. What do they want us to add an assert error function. Interesting. I wonder if it's actually even worth it to extract this function. So instead of saying assert balance, we'll call assert error. All right, I guess so. So for the helper function, we're not going to actually declare that using func. We're actually declaring this using just a colon equals. So we're putting it into a variable. I think that's fine. It's a, I guess we would call this like, we call that first class functions. So this would make it easier for us to test different kinds of errors in the future. That could be nice. Great. So I'm going to make this assert error function. I think in a larger code base, you might want to have some sort of error library that you're using. On the Cockroach Cloud team, I think the one we use is called Testify. Testify/require, I believe, is the thing. So yeah, let's iterate on the error message. Oh no is not very informative. Ooh, yeah. So we're gonna update the test helper so that it actually compares the error to what we're expecting. That's nice. So instead of just saying it wanted an error, we actually need to check the string of the error. That's cool. I really need to get like an automatic formatter for my code. So let's see. Pasted their little helper there, and then I'm going to need to call it in some interesting way by doing want as a string. So first I'll pass the string oh no, I guess. So they want us to write cannot withdraw insufficient funds. Sounds good. And yeah, if you're writing software that other programmers are going to be working on, or even if your errors are going to be exposed to users, it's always nice to have something more like cannot withdraw insufficient funds as opposed to just saying, oh no. I think a lot of programmers, like maybe they put in error messages and plan to change them later, and then they kind of never get around to it. I've certainly done that in the past. So now we need to edit the original file. I'm going to actually skip down to formatting this error. We have a duplication of the error message in both the test code and the withdraw code. It would be really annoying for the test to fail if somebody just wanted to reword the error, and it's just too much detail for the test. We don't care what the exact wording is, just that some kind of meaningful error around withdrawing is returned. I'm curious if people agree with this philosophy. For me, I might be like, I don't know. Part of the whole point of a unit test is that sometimes you do want to write things twice. It's kind of a double check. Ideally, you want to write them in somewhat different ways. But yeah, let's make this error insufficient funds type. I like that. So we're defining that here right above the, I don't know, I kind of want to, it feels weird to define it in the middle of the wallet. I kind of want to put this up at before the wallet. But you know what? I don't even like this because I want to put in in a better error message. It looks like that's just not in this chapter, but I might have to go off of the rails and return an actually good error. In my opinion, this thing it's not a good error because it should tell you the balance and tell you the amount. That way somebody will know, oh, like, did I put in the wrong amount to withdraw? Or maybe I actually don't have the amount of money in my wallet that I thought I had. So there's definitely a way to format an error. I think the thing that I was looking for is format.errorf. And then I can cannot withdraw And then I'm going to put the amount, which is a %s because I want it to print BTC. Cannot withdraw, let's say 20 BTC from wallet with only, and then I'm going to print out the balance. And I'm going to use, this is a use of variadic arguments, which we learned, I think, in episode number 3. So amount and then w.balance. And this should print out a pretty informative error message. Let's run the test to see if it works. Okay. So I'm in trouble with the Go compiler because I'm no longer using this errors import. So I have to remove that. That's fine. Okay, so the error message is looking actually great. Cannot withdraw 100 BTC from wallet with only 20 BTC. I like that error message a lot. And I think it's always great to include the specific data, as much specific data in your error message as you can. So now I'm going to fix the test. Cannot withdraw 100 BTC from wallet with only 20 BTC. And I think there's this is kind of a backwards test driven development where I actually I wrote the test, then I ran the test, then I looked at what it output and I'm like, oh yeah, I should just put that over here into the test. That's a little backwards from normal TDD because in normal TDD, you want to define your desired result before implementing the logic. But whatever. So I'm going to do a commit here, which is, let's do a format first. Go format dot. And let's do a git commit. Informative error message, I think, is going to be the name of the commit. So I think this idea for defining a new error, it's a good idea, and I should probably do something. Nathan Stillwell says test-driven test development. Yeah, exactly. I mean, honestly, I'll admit it. Sometimes I will just I'll write the function and I'll see what it outputs, and then I'll copy paste it into the expected output of the test. I know that that's not really cool in TDD, but it's really, I don't know. I mean, I'll look over the output and see does that look good? And if it looks good, I'll just copy paste it. It's probably going to be bad a certain proportion of the time. So what we really want, we do want a variable for this insufficient. We want a type for this insufficient funds thing, and then maybe we would have a stringer or something that will print the error out as a pretty string. I actually don't know the way to do that in Golang, but I'm pretty sure there is going to be a good way to do it. Maybe not though, because is error a type? Is it a struct or is it an interface? I think it must be an interface. I bet we're going to learn more about that in the future. So now this thing wants us to do more refactoring. Are people interested to see that? I'm kind of thinking, let's just skip the refactoring. Let's do unchecked errors. There is one scenario we have not tested. To find it, run the following in a terminal to install error check. Oh, okay. Wow, that's fun. What scenario have we not tested? One thing that I'm thinking of is an integer overflow on a deposit. If we already have the maximum int amount of Bitcoins and we try and deposit 10 more Bitcoins, Is that gonna cause a problem? Oh man, what is this function? So I'm very intrigued by this scenario that we have not tested. Does anybody have an idea for what's the like final possible remaining error here? Balance, I think this is fine. I don't think that, oh, can an int be negative in Golang? What if we pass in a negative amount to withdraw or something like that? And then, I don't know. So yeah, we're gonna run aircheck dot. I wonder what this, oh, it's a linter, okay. So line 35. Oh, what? Ah, that's really cool. This is actually a really super useful lint. So what this is saying is that we have not checked that on a successful withdraw, an error is not returned. In our test code, that, so let's see, when we do a withdraw, so we're not even getting the error back. So first we're gonna have to get the error back, and then maybe I'll pass the error into like assert balance or something like that. Assert no error. Okay. Is that a, I think that's a new function that we'd have to write. Yeah, I like that. So this means that we could accidentally be like ignoring an error. And that's pretty bad practice. In this case, our code, I think, happens to be correct, but I think we really should be checking this. So let's do this assert no error function. For some reason, these are now funcs instead of being defined as variables. I'm not sure why they chose to do that. This is a very refactoring heavy book, but maybe it's a good practice to show that the code can be structured in different ways and still work the same. So let's do a go test dot. Uh-oh. I think I messed it up because, yeah, I don't know. Oh, I need to pass t into this function. So whenever you're in a testing context in Golang and you want to make like a test assertion, you have to pass this t testing around. And I think that it's kind of nice. It's an explicit way to keep track of your testing context. So go, yeah, I'll do a commit and check error from withdraw, or check no error from withdraw. So what we're actually doing is we're checking that the error is nil. And if we rerun air check on the current directory, it does pass. So that's great. All right. So I think we made some pretty great progress today. I'm actually interested in getting deeper into the error handling system. I think there's a lot of interesting questions that we did not talk about with errors. For example, how do we implement our own custom error that could have like a customized print statement like the one that I implemented by hand? How do we have errors wrap other errors? Are there other linters that we can use to make sure that we're checking our errors or handling errors in the right way? And then there's also a bunch of really cool stuff that we can still learn about with pointers. Like, can we do any kinds of weird pointer arithmetic? Can you have a pointer to a pointer? And we actually didn't get too much into referencing and dereferencing. We kind of just reviewed those operators, but I think there's a lot more to learn about these topics, although it's probably going to take a while to get there. So what did we learn with pointers? Go copies values by default. And if you want to modify something that was passed into a function, you need to make sure that you have a pointer to the data that you want to modify. And pointers can be nil. I guess that's the same as what other languages would call null. And when we've got errors, we return it from the function as the first return value. And yeah, we're going to learn more about them in future sections. And we can we also learned about this a type alias where we declared our own Bitcoin type, and that makes sure that we don't accidentally pass in an int as a Bitcoin, and it also let us have some custom print statements. So next it looks like we're going to be learning about maps. That's pretty fun. That's obviously a super key data structure in pretty much any programming language. We already learned about arrays and slices, but maps will let us do some lookups more efficiently. So definitely looking forward to that next week. Thanks to everybody who tuned in, and looking forward to learning about maps in a week.